Okay, so let's start by doing some exercises, some type of questions that you're going to be doing. So let's practice first our trigonometric ratios. So the example says, write the trigonometric ratio that relates the two given sides and the reference angle in each of the following triangles. So we just have to write the trigonometric ratio. Okay, fantastic. So the steps that we need to follow are, first we have to copy the diagram and label the given sides. I'm not going to copy the label diagram because it's going to take me forever to draw these triangles that I already have here. But because you're doing your questions on Jack Plus, then you need to copy these triangles into your book and label them, okay? Identify the trigonometric ratio, then we substitute the values, and then we're going to simplify the fraction. Fantastic. So here, which one is our reference angle? Is this angle B. So because this one is our angle B, then I know that this one is going to be my opposite side. And my hypotenuse is going to be this one. Okay, so ka, to, a. Which one is going to be my trigonometric ratio? So it's going to be sine. So it's going to be sine of B is equal to opposite over hypotenuse. So the sine of B is going to be equal to 6 over 15. And we can simplify that by dividing both numerator and denominator by 3. So this one is going to be equal to 2 over 5. Fantastic. So that's the first one. Let's look at question B. So here we have angle B, that is the angle of reference, that is 50 degrees. And here we have, this one is going to be our opposite side. Agree? And this one here is our adjacent side. So ka, to, a. So in this case, we're going to be finding the tangent. So the tangent of 50 degrees is going to be equal to x over 18. And in this case, I can't simplify it anymore. This type of question is not asking me to find x. We're going to do a question later on trying to solve for x, but for the time being, it's just asking me to write the trigonometric ratio that relates to the angle. So I'm going to leave it there. Another example. This one is about calculating unknown sine lengths. So it says, use the appropriate trigonometric ratio to find the length. So here we're being asked to find the length of the unknown side in the triangle shown. Give your answer correct to 2 decimal places. Okay, so our steps are here, the same ones as before. So first we have to copy the diagram and label the given sides. Identify the trigonometric ratio, substitute the values, calculate and round the answer as required. You know what? I'm going to find a highlighter here, this one, because here it's asking me to highlight to 2 decimal places, and I'm going to highlight that so that I remember that I have to do that. Okay, so I have my right angle triangle. The first thing that I need to do is label it. So let's see. This is my reference angle here, 58 degrees. So the opposite side is this one. So I'm going to call this one is my opposite side. And then I have my adjacent side, that is 16 and 2/10 meters. And then I have my hypotenuse, but I don't have any value for my hypotenuse. So what is the trigonometric ratio that I need to find? So ka, to, a. So I have the adjacent and the opposite, so it's going to be tangent. So let's do it here. The tangent of 58 degrees is going to be equal to so ka, to, a, opposite over adjacent. So it's going to be opposite over adjacent, and then I sub in, so it's tan of 58 degrees is going to be equal to x over 16 and 2/10. Perfect. Now, how do we solve for x? So tan of 58 is the same as any operation that we have. So how do we will do this normally? We have to find how do we will solve for x? What do we have to do? I'm going to do it step by step just because it's the first time. So what would I do? I will times both sides of the equation times 16 and 2/10, and I'll do the same thing on the other side. So when I do that, I can cancel this one and this one, and I have, and I'm just going to rewrite it so it looks nicer. I don't know why with black is looking so awful with those numbers. I think I have to change the pen that I'm using. We'll see. Okay, so x is going to be equal to 16 and 2/10 times tan of 58 degrees. Now, let's do this in our CAS. So we go to our CAS, and I'm going to write 16 times 2 times, and here you will see under this control thing underneath here we have the equal, and then we have trig, and if we press in trig you will see that all of our trigonometric ratio appears. Other ones will appear that you're going to learn later on, but for the time being, what we have to do, I think it was tangent, so we have to do the tangent. This is not going to work, and I'm going to tell you why it's not going to work, because it over here says radians. So it's good that this happened, because we all have to change this to be degrees. How do we do that? So we have to go to our document, and we have to go to settings. Where is settings? Number 7, settings. Oh, my goodness me. Again, document, settings, patience, document, settings. Okay, there we go. Document settings, number 2. Okay, and here where it says angle, make sure that you have degree. And then, okay, perfect. Now I have degree. Now it's going to work. So I go and say, okay, my trigonometric ratios, and it's going to be tan of, what is the angle that I needed to do? 58 degrees. And we press enter, and something weird comes up. We have to press, remember that we have to press Control enter, and then we have our value. How many decimal places? We need 2 decimal places. So I look here, I have the 9, the 2, and the following is a 5. So it's going to round up. So it's going to be 25 and 93/100. Okay, so our x is going to be equal to 25 and 93/100. What am I looking here? Remember that here the adjacent side was saying that it was in meters, so this side is also in meters, and that's going to be our answer. Fantastic. Okay, let's do another example. So this one is about calculating unknown angles. So in this one says, determine the value of theta in the triangle below. Give your answer correct to the nearest degree. Okay, so we have, this one is going to be slightly different, but you're going to see that is the same logic behind. So it says copy the diagram and label the given side. So let's label it. So I have my reference angle, which is theta. Therefore, I have my adjacent here. That is going to be this 12. And I have my opposite. My opposite will be here, but I don't need the opposite because I have the hypotenuse. And the hypotenuse is going to be this one, which is 63. Great. Now, identify the trigonometric ratio. So ka, to, so I have cosine. So let's write it here. Cosine of theta is going to be equal to adjacent over hypotenuse. So cos of theta is going to be equal to adjacent, which is 12 over 63. And what do we do now? How do we solve for theta? So all of our trigonometric ratios have an inverse. So we can find the inverse of cos. And I'm going to show you how we do that in the calculator. So in the same way that we will do like the inverse operation of on both sides. So in this case, what we're going to do is that theta is going to be equal to the inverse of cos, and we write it like this. That means that is the inverse of cos of 12 over 63. And that's going to give us our value of theta. So let's go to our CAS. Okay, we're here in our CAS. I am in degrees, all good. I just want to show you, in case that you are crazy like I am and you need a clean page every time, so you can go to doc, and I think it's not here. No, it's you see it in the Scratch. If you go to Scratch, is when it works here. If you type something like 3 times plus 2, 5, and then you want to clean that, you go into doc and press B. B is going to clear it up, because if we go into doc and we go down, you see there was, I hope you were able to see it. Okay, so I'm going to find what we were doing, the inverse operation of 12 over 63. So how do we do that? We go again to our trigonometry, we find the inverse of cos, and we just have to press 12 over, just notice that I press Control and I'm going to write division, just to write this as a fraction, 63, and then I'm going to press Control Enter, and I have here my angle. It said that I had to find it to how many, to the nearest degree, so I don't have to round, I have to run it to the nearest whole, to the nearest unit. So it's going to be 79, because my first decimal place is a 0. So I write my answer. My answer is theta is equal to 79 degrees, and that's going to be our answer. Great.